Good morning, good afternoon, and good evening, esteemed guests, participants, enthusiasts from all around the globe. It is truly a privilege to see so many virtual faces joining us today. The very essence of collaboration and the sharing of knowledge is what has brought us here today. The webinar will commence in a few minutes' time. As we wait for other participants to join in, I invite all of you to engage in the chat box, perhaps share where you're tuning in from, or what is that one thing you're trying to gain out of today's session. Let us make the most out of our shared space and time. Once again, thank you for being here and stay tuned. The webinar will commence in a few minutes. Once again, welcome back. Good morning, good afternoon, and good evening, esteemed participants from diverse backgrounds and industries. It is an absolute pleasure to welcome each and every single one of you into today's insightful webinar on machine learning and predictive analytics, a deep dive into ONNX Runtime. My name is Srinivas, and I'll be navigating you through this enriching journey of exploration and understanding. Now, before we deep dive into today's webinar, let me give you a couple of points and agenda points to go over. The webinar presentation will happen for 30 minutes, and the presenter will continue their narrative uninterrupted until the presentation is over. And once the presentation is over, we will have our Q&A session for 20 minutes. Feel free to drop your questions in the chat box as we progress, and we will try to address as many Q&As as possible during the segment. All of the questions will then be collated and then sent to you in a couple of days' time, along with the recording of the event to all of our registrants. And in order to maintain dignity, the webinar will be in listening mode only for the audiences. Now, before we move on to the actual webinar, let me give you an industry outlook on machine learning and ONNX Runtime. In the rapidly shifting sands of artificial intelligence, tools like ONNX Runtime offer stability and promise. As we forge ahead, embracing such tools will be key to unlocking AI's true potential. In the grand theater of AI, if ONNX is the script, ONNX Runtime can be called the director, ensuring that the show runs without a hitch. It promises three things: versatility, performance, and integration. And as more organizations embrace AI, the need for models to be framework agnostic and efficient becomes incredibly paramount. ONNX Runtime is poised to be that enabler, pushing the boundaries of what's possible in AI deployments. So with this outlook, let me now welcome the speaker for the day. Ladies and gentlemen, I'd like to welcome Soundar Tyagarajan. Good morning, Soundar. I hope you can hear me. How are you doing?
Srinivas, I think I'm not able to turn on my video. Should it be enabled? It says the host has stopped it.
Oh, that's all right. That's not a problem.
Okay.
If you can hear
Got
me.
it. Okay. But am I audible?
Yes, you are. Yes, you are.
Okay, perfect.
Thank you so much, Sounder. So let me give you a small introduction on Sounder. Rooted in his profound interest in photography, Sounder has actually developed a significant passion for computer vision. He possesses an advanced academic background with a master's in computer sciences, focusing especially on machine learning. Sounder has begun his professional tenure at Ericsson Analytics and then subsequently joined Multicoreware and contributed his expertise to the Multicoreware team. He is poised to share invaluable insights into ONNX Runtime, detailing both his hands-on experience and his contributions. Furthermore, he will elaborate on what Multicoreware's perspective is on that matter. So let us all accord a warm welcome to Sounder. And with that, Sounder, the stage is all yours.
Thank you, Srinivas. Thanks for the introduction. Thanks everyone for joining. Hope this session will be informative, and we'll chat like more in the Q&A session. Thank you.
Thank you very much, Sounder. Let me go ahead and present my screen to everyone.
Hello everyone. Good morning, good afternoon, and good evening to all of our audiences. I'm Sundar Tyagarajan. I work as a technical project manager at Multicoreware, and I'm delighted to be here today with you all to discuss machine learning and predictive analytics with a focus on ONNX Runtime as an inference engine. Let us dive into the topic. What exactly are machine learning inference engines? To elucidate, consider this analogy. Imagine you've trained a model and are ready to deploy it. The deployment isn't always on a large-scale system like multi-GPU setup, a data center, or even your personal workstation. More often, it's on an edge device. For instance, if you aim for pedestrian detection in an autonomous vehicle or face detection in a security camera, you're looking at smaller systems or on-chip on-site rather than expensive setups. Inference engines play a pivotal role in various scenarios. They assist in executing models, leveraging hardware acceleration tailored for edge devices, enhancing compatibility across different frameworks, and aiding in both pre- and post-processing of collected data. Notable examples of inference engines are TensorFlow, TensorRT, TF-Lite, and ONNX Runtime. With the latter being our main focus today, each of these engines comes with its unique set of advantages and limitations. What exactly is ONNX Runtime and how does it distinguish itself from the plethora of inference engines we have touched upon? Delving deeper, ONNX Runtime stands as a premier open source high performance inference engine. It's bolstered by a vast and vibrant community which ensures it remains at the forefront of innovation. Not only does it play a pivotal role in enhancing the cross-platform compatibility of your models, but it is also impressively framework agnostic. Its plethora of graph optimization makes it incredibly efficient, elevating its performance parameters. A key strength of ONNX Runtime is its ability to foster interoperability. Whether your goal is deploying algorithms across various hardware configurations or venturing into the realm of edge computing, ONNX Runtime stands by you, ready to assist. Moreover, model conversion is another significant area where ONNX Runtime shines. No matter which neural network framework serves as your starting point, if your end goal involves running the model across diverse platforms, transitioning to the ONNX format becomes seamless. Think of ONNX Runtime as a versatile intermediary, adept at converting mirrored formats into ONNX and vice versa. With the core executions leveraging the ONNX format, the process of transitioning from any neural network framework becomes even more straightforward. In summation, ONNX Runtime streamlines the deployment of machine learning algorithms, ensuring peak efficiency and optimization every step of the way. On your screen right now is a visual representation of the ONNX Runtime framework. As you can observe, to the left you have the neural network frameworks like PyTorch and Keras serving as examples. Upon training your model using these frameworks, the subsequent step involves converting it into the ONNX format. Once this conversion is achieved, the ONNX runtime steps in facilitating the execution of this model into a format optimized for deployment, whether it be on CPUs, GPUs, FPGAs, NPUs, or any other computational platforms. This bird's-eye view of the ONNX runtime framework underscores its chief advantage: the unparalleled cross-compatibility it introduces. It not only bridges various platforms but ensures that your model's deployment is smooth and efficient across diverse hardware ecosystems. Having established a clear understanding of what ONNX Runtime is and its foundational framework, let's pivot towards a typical workflow when utilizing ONNX Runtime. To commence, given the assumption that you already have a trained model, the preliminary step involves and revolves around preparing this model for the ONNX environment. This preparation involves loading your model directly into ONNX. It's imperative to note that this phase is typically executed post the graph optimizations pertinent to your model, ensuring optimal performance. Following this is an inference session is initiated. As you embark on the session, you are tasked with preparing the requisite input data, setting the stage for the actual inference process. The culmination is the execution of the inference, allowing you to derive insights from your model's predictions. After successfully navigating through the initial steps, the next phase involves processing your input to obtain an inferenced output. Depending on the type of model, the nature of this output might vary. For instance, in situations involving a convolution neural network, the resulting output is predominantly numerical. This might necessitate a translation into bounding boxes, especially when the model pertains to object detection of similar tasks. No matter the format or complexity, ONNX Runtime is adept at inferencing. Following this, it proceeds to produce a tangible output, efficiently manage resources, address any potential errors, and consistently monitor performance metrics to enable further refinements. ONNX Runtime, in essence, functions as a comprehensive tool that spans the breadth of the ML pipeline. From the nascent stages of data preparation to the intricate nuances of resource management, its prowess lies in its capability to amplify the efficiency and performance of diverse platforms, ensuring optimal results throughout. On your screen now, you are presented with the detailed architecture of ONNX Runtime. As we delve into its intricacies, you'll unmistakably recognize the alignment with the workflow steps we elaborated on earlier. Initiating our journey, the ONNX model section houses your trained model in its designated format. Upon this establishment, the model is ushered into the in-memory graph. Here, the intricate dance of graph optimization unfolds, all the while harnessing the full might of the available hardware capabilities. Given the modern hardware landscape, multi-core and multi-thread architectures have become the norm. Leveraging this, ONNX Runtime makes a strategic shift to parallelize tasks. This maximizes efficiency, ensuring rapid inference completions. And this is precisely where the distributed graph runner becomes as an invaluable player. From here, the model transitions to the execution providers. These are specialized entities tuned to the nuance of various hardware, be it GPUs, CPUs, or other platforms. They exploit the hardware-specific libraries to execute models seamlessly. The crux of this entire architecture arguably lies in the execution provider's domain. Given the multifaceted nature of this section, it's worth closer examination. Thus, in the following slides, we'll embark on a deeper exploration of execution providers, unraveling their intricacies and highlighting their significance in the broader ONNX runtime architecture. Let's delve into understanding what exactly an execution provider is. At its core, every platform is equipped with its unique set of optimizations tailored specifically for ML inferencing. Some even go a step further, boasting their dedicated ML inferencing engines. Execution providers serve as a bridge, enabling you to tap into these platform-specific optimizations and harness them with the ONNX Runtime ecosystem. Now, a natural question that might arise is, if every platform comes with its own inference engine, why should one opt for ONNX Runtime as the intermediary? Why not directly engage with the platform-specific inference engine? Certainly, going direct is an option. However, if your vision encompasses deploying your model across a diverse range of hardware, the challenges compound. Suddenly, you find yourself navigating through the intricate maze of writing distinct inferencing code tailored to each platform. Additionally, there's the uphill task of mastering a unique set of APIs for every platform to fully exploit the vendor-specific optimizations. This is where the true magic of ONNX Runtime reveals itself. With ONNX Runtime, you craft a singular unified inference code. At runtime, you simply select the execution provider best aligned with your current platform. And what's the result? A harmonious fusion of efficiency and versatility. You gain the advantage of enhanced portability without being bogged down by the daunting prospect of penning myriad codes. Moreover, as the tech landscape evolves and new platforms emerge, ONNX Runtime's adaptability ensures that you can effortlessly onboard these platforms once their respective execution providers integrate into the ONNX ecosystem. Certainly, with ONNX Runtime's execution providers, there is no need for rewriting. All adaptations occur dynamically at runtime. To encapsulate, execution providers primarily offer these key three benefits: hardware acceleration, cross-platform compatibility, vendor-specific optimizations, and further expanding its advantage as execution providers deliver. Some of the other advantages to add on is scalability, parallelism, memory efficiency, and diverse platform support. Processing further, execution providers play a pivotal role in elevating performance while also offering avenues for fine-tuning, customization, and real-time application deployments. Wondering about some real-world examples? Yeah. Platforms such as TensorRT, OpenVINO, and CUDA have readily integrated execution providers tailored for ONNX Runtime. Thus, by embedding ONNX Runtime into your workflow, you're not just accessing the inherent benefits of the runtime itself, you're also harnessing the capabilities and enhancements that these established platforms offer, all from within your existing ONNX Runtime application. Building on our discussion, let's recap the realm of execution providers in ONNX Runtime. For CPUs, there's a default option which is MLAS. If you have specific needs or preferences, you can opt for the alternatives like Intel DNL and others. Shifting our gaze to GPUs, Edge, and other diverse platforms, ONNX Runtime offers compatibility with their respective inference engines, ensuring you have a broad spectrum of options at your disposal. It's essential to note that this isn't exhaustive catalog. Given the open source nature of ONNX Runtime, the door is always open for contributors to add support for new execution providers. This dynamic and collaborative environment ensures that ONNX Runtime remains adaptable and ever evolving, aligning with the rapidly changing landscape of machine learning and hardware platforms. Let's take a step back and view the larger picture. On one side, we have the versatile inference engine, and on the other, we have the ONNX Runtime, a tool tailored to streamline and enhance the inferencing process. But a pertinent question arises: What role has multicore played in enriching the ONNX runtime? Windows employs a feature called processor group where it bundles 64 threads into one group. ONNX runtime didn't have support for more than one processor group to start with. This created limitations for systems with more than 64 threads and couldn't unleash their full potential. Only the first 64 threads would be used and the rest remaining unutilized. This setup throttled performance on more capable systems, denying them the opportunity to reach their max potential. Identifying this glaring inefficiency, multicore intervened. We spearheaded the integration of support for multiple processor groups within ONNX Runtime. This enhancement spanned both the core ONNX Runtime as well as parts of Eigen repository that the runtime relies upon. Consequently, systems endowed with more than 64 threads experienced a dramatic boost in inferencing speeds. Your contribution didn't halt there. As a semiconductor vendor, sought to gauge the performance of popular models using ONNX Runtime on their platforms, they turned to ONNX Runtime's built-in performance test. However, these tests had an Achilles heel. They lacked parallel inference support. Even with the multiple processor group compatibility, if parallel inferences couldn't run, high thread core systems remained underutilized. Recognizing this bottleneck, multicore infused parallel inference capabilities, thereby amplifying throughput on systems with high thread counts and bolstering the overall efficiency of these processes. Multicore's foray into ONNX Runtime showcases just a fragment of our comprehensive suite of services. As a company, we are unanchored to any specific platform or hardware. Our essence is platform agnostic. So, what breadth and depth can we offer within the expansive universe of deep learning? To frame it successively, Graph Compiler. Our journey often begins here. If you possess an ML accelerator or a specific platform for ML inferencing, a graph compiler tailored to your ML framework is crucial. What's our role here? Transitioning operations from one intermediate representation to another, graph rewriting and optimization, efficient scheduling and assignment of operations. Our offerings envelop every facet of a machine learning compiler, fine-tuned to align with your distinctive needs. Then moving on to kernel libraries. A level deeper, neural network layers and their kernel libraries are pivotal. Here we dive into the hand optimized strategies, introduce new layer support, and vectorize pre and post-processing functions. Our focus remains steadfast, boosting compatibility and efficiency. ML frameworks. With the foundational components in place, we turn our attention to runtime frameworks and training structures, and Multicore steps into seamlessly integrating framework and vendor APIs for neural network execution. Offer backend support tailored to specific hardware and ML paradigms. Enhance runtime frameworks, including stalwarts like ONNX and TensorFlow Lite. Additionally, we can seamlessly weave execution provider support into the ONNX Runtime fabric, expanding your platform's accessibility and utility. Size reducer. Sometimes the optimizations required reside at the model level. Once your model is primed in terms of accuracy and features, the quest for speed and efficiency begins. That's where we step in with model pruning and compression, striking a balance between size and accuracy, quantizing model weights without compromising the integrity of the model's accuracy. Then, once we have all these in place, we can move on to model zoo, ascending to the apex Our expertise extends to characterizing ML models, crafting a model zoo, benchmarking, fine-tuning parameters, optimizing batch sizes, and even constructing robust CI/CD pipelines. While this rundown provides a snapshot of our offerings, it's by no means exhaustive. Our commitment is holistic, spanning the entire ML stack. Our endeavor is not just to cater to your specific needs, but to democratize machine learning, making it intuitive, efficient, and universally accessible. And now we have reached the end of this webinar. Thank you all for joining today's webinar on the ONNX Runtime. We hope you have a deeper understanding of how this powerful inference engine can optimize and streamline machine learning operations across a variety of platforms. We appreciate your time and engagement, and we encourage you to further explore ONNX Runtime's capabilities as it continues to drive advancements in the machine learning community, as well as explore multi-core web and what we have to offer in the ML space. Please don't hesitate to reach out with any questions in the Q&A session or for additional resources. Until next time.
Thank you very, very much, Sounder, for that wonderful session. Is there anything you'd like to say?
Thanks, Srinivas. I hope the session was informative, and this is obviously just an introduction and a seed for thought for everyone to go explore into ONNX Runtime and ML inference engines, and also a teaser into what multicoreware has like contributed in the space and what we can offer. And yeah, feel free to ask your questions in the chat box, and then we can start the discussion.
Thank you very much for the session, Sandar. We hope everyone in the audience enjoyed it. And I personally hope that you learned something new from this webinar. So let us now move on to the Q&A session swiftly. This session will last for 20 minutes, respecting everyone's time. So the audience has two options here. Number one, you can raise your hand and we can unmute you and you can ask your questions personally, or you can put it in the chat box anonymously, which will be taken up and then answered in the call right away. We already have a bunch of questions from the audience here. So let me now quickly invite the panelists. One of them will be Soundat Tyagarajan, and the other one would be Naveen Krishnan, who is also present here with us. Naveen, can you hear me?
Yes.
Hi.
My voice is audible?
Yes, you are audible, Naveen. Thank you very much. Naveen Krishnan is the technical unit head for frameworks and tools for multicoreware. And as always, Naveen, it is a great pleasure having you here. So let us now begin with the first set of questions, which I have here in front of me. So let us start with you, Naveen. So one of the questions that I got was, why would a developer choose ONNX Runtime over any native framework runtimes?
Yeah, hi all. So it basically depends on what is the deployment target or the constraints of their IP. So basically, I would say I would say that if their focus is to run the models on the from the multiple frameworks, right? So the ONNX would be the better interoperability, and it also helps the cross-platform deployment. So it's best to choose ONNX runtime for that, for the versatile option. At the same case, like if their development is purely only on the TensorFlow models and they want a little more fine grained control over their ops, and if they need to do some custom ops for specific TensorFlow based models, then TF like Delegate would be the better option. But if you're looking for different frameworks, then ONNX would be a little more flexibility.
Thank you very much, Naveen, for that question. I hope the person who asked the question has had his or her question answered. Speaking of, so how does ONNX Runtime support edge deployments, if we were to talk about that?
So when it comes for the edge deployment, there is a lot of constraints over it. For example, like with a limited compute power, memory, and so on. So where the ONNX runtime is very lightweighted, which is like on C, C++, and it is like cross-compatible on any operating systems. And also like you have it also helps in running on the RTOS, so on the real-time performance it gives. And basically, like you can go off with that. And also for the edge devices, if you ask, so you need to have a execution provider. So for example, like if you have the target already having the execution provider, then you can take the benchmark. Or else Multicore were also specialized in supporting the ONX runtime for specific IP providers, and we do also support adding their hardware to the ONX runtime at the backend support.
Thank you. Thank you very much, Naveen. And once again, I hope the person who answered the question has had his or question answered. So, Sounder, if I may ask you one question from the audience. So how does ONNX Runtime exactly ensure optimized performance across all platforms?
Okay, so ONNX Runtime has like very good graph optimizations. So once you feed your ONNX format, like the graph optimizations offers a certain level of performance improvement, and after that, like the other set of optimizations, what it can provide is using its execution providers, as we discussed. So when it gets to the specific platform, then the execution providers helps it leverage the vendor specific optimizations. So these two coupled, and then the features when it provides regarding performance monitoring and fine tuning, all these combined together, ONNX Runtime helps you achieve the max performance you want to in most cases.
Thank you very much, Sounder. And just continuing on that topic, so of course, ONNX Runtime is a wonderful tool, but what are some challenges that one might encounter while using the tool itself?
The challenges one might encounter is, to start with, it has like less entry barrier compared to other inference engines, because since ONNX format itself is like a universal format, converting any model into it is easier. So in that case, it like the entry barrier is easy. But again, some of the execution providers, like especially when you go to some of the edge platforms, like they are still in the preview stage. So like the default ONNX runtime you get out of any of the releases are just for your default CPU MLAS. Recompiling ONNX runtime with the execution provider of your choice, and especially if it is in the preview stage, maybe you may not get all the benefits of the vendor specific optimizations. So these are some of the challenges it can pose in getting it up and running easily for specific hardware cases.
Thank you very much, Sounder. One interesting question, which, well, I personally found this super interesting, is once we have the model converted in ONNX Runtime, will it be better to inference it using ONNX Runtime or to go to TensorRT? So, Naveen, would you like to take up this question?
Yes. So when it comes for the deployment environment, right? So if it is purely on the NVIDIA GPU, if you want to run an end-to-end model, okay. So the TensorRT would be the strong choice. But if you are going for specific tensors, if it is not supported, and if you want to have CPU execution along with tensor or some other devices to it, because of the broad varieties of support, right? From the ONNX runtime, so that it will make sure that your model runs successfully. So then my choice would be for ONNX runtime.
Understood, Naveen. Yeah, and speaking of integration particularly, we have another question here. So how does the integration of machine learning models with predictive analytics benefit from ONNX and in its runtime?
So if you take for the predictive analytics, right, the goal is to leverage the historical data to make the prediction better, right? So on the decision making and improve the outcome. So when it comes for the ONNX runtime, right, as we are speaking now and then always, so the interoperability, which is always helps you here, because like if you want to have multiple models at the end, and similarly ONNX runtime provides the support of supporting different models can be converted into an simplified IR representative, which is the ONNX, and you can run it together. So, and also you have the end-to-end ecosystem ONNX, which provides where the developers, where the big giants also invest a lot there, and you get now and then the new offsets. So going for the ONNX runtime here would always gives you a better option here.
I understand. Yeah, thank you very much, Naveen. I also had another question with regards to the new players that you just mentioned. We also have another question with regards to that. Sandor, if you may answer this question. So there is a new modular runtime available in the market. Why to choose ONNX Runtime specifically over this new runtime?
So yeah, there are a lot of new players in the market. So one of the advantage with ONNX Runtime is its open source nature. So any specific bug you find out, any specific deficiency you find out, like you have access to the source code, you can go contribute, or even like you can make a local change and you can make it work for you. And again, it's currently supported across a variety of systems, and the optimizations, and since it's like widely adopted by most of the semiconductor vendors, its performance and its like ease of use and the APIs it provides is a lot more mature, I would say, at this point. But that said, like there are other good players coming onto it. Only time will say how ONNX Runtime holds up. Yeah.
Thank you, Sundar. And speaking of ONNX Runtime, ONNX Runtime also has a huge community for support. So your answer validates that. So moving on and continuing on that, are there any visualization tools or utilities to better understand ONNX models? Sundar, if you may.
Yeah. So there is this tool called Netron, and it can like feed in ONNX models, and it provides you a very detailed visualization of your entire model with every layer and the kernel size. So it helps you like debug or also like re-architect your model in that case. So yeah, Netron would be the go-to for ONNX models.
Understood. Thank you very much, Sounder. We have quite a lot of questions pulling in. I'm not sure if we have enough time to answer all of them, but we will try nevertheless. So another question we have is the model compression to ONNX using the weights of the model, suppose ResNet, the complete conversion of the architecture, or just with respect to that checkpoint? Naveen, would you be able to take up that question?
So here, right, the ONX is basically an intermediate representation, right? So you convert the graph from one structure to another structure. So it doesn't matter, because you give a model, if it is from, if you take in the ResNet, right? If it is from TensorFlow and you convert into the ONX, then the conversion happens for the whole checkpoint where it converts into an ONX representation of graph, which that graph can execute in any is the universal structure where it can execute by any supported graph format, or even it can run on the ONNX runtime.
Understood. Thank you. Thank you very much, Naveen. And I hope the person who asked the question has it answered. Continuing on, can you tell us a little bit more about ONNX Runtime CPU and GPU? We discussed it as a very important part of the presentation. Naveen, could you tell us about that?
Okay, so basically, right, the ONNX runtime, what it does is, right, at the front end, it supports with the ONNX graph, and similarly at the back end, right, as an execution provider, you can add any of the CPUs or GPUs or even hardware accelerators at the back end support. So here the runtime makes sure that if the model is supported by the ONNX, then it makes sure that the model will run and you'll get the output. That means internally, like only if the certain layers supported by the CPUs and certain layers supported by the GPUs, it doesn't matter. So the ONNX runtime will divide the graph into many subgraphs based on the backend support, and similarly execute those specific subgraphs alone in their hardwares, like whether it is a CPU or GPU.
Understood. Thank you. Thank you very much, Naveen. And of course, the support for this is just ever evolving. Just like the next question that we have is, how does ONNX handle evolving machine learning architectures and operations? Naveen, may you answer that?
So as we know that the machine learning keep on evolving, right? Like each day to day we see a paper, and each day to day, like we see a new operators comes alive. So the ONX is in very it's an extensible, and the big giant supports the ONX community, and a lot of operators have been keep on adding by the open source contributors. So right now, if you see, right, opposites, right now it has been in 20. or the offset 20 version has been there, and similarly it supports more than 130 above plus of version of operators within the ONX. So we see that there is a big community-driven development has been happening. And similarly, apart from that, right, not only on the open source communities help, if anyone wants to develop their own custom operators, right, even like any developer can have fork it and can have a support on your own for the specific custom operators, and you can run or you can even try to train along with that as a custom operator. So that flexibility also it provides.
True. And yes, we did also speak about the flexibility of the tool as a whole during one of the slides in the presentation. Thank you very much, Naveen. So if I may invite Sounder for another question that we have here. So how is ONNX helping in democratizing artificial intelligence and machine learning? Sounder?
Yeah, so in that sense, it's providing a more standardized and like open source community to start with, and again, like adding the execution provider support makes it more portable, and especially the cherry on top is the ONNX format, which is the open neural network exchange format, providing a more universal conversion medium for like any neural network framework, like a model trained using any neural network framework. So put together, these things are like helping ONNX Runtime like democratizing at this point. Hope to see like more open source players in this space. Like always, like competition makes things better.
True. Healthy competition makes everything better. Speaking of something I'm very interested in, Sounder. So how does ONNX Runtime handle large models or data sets during inference?
So like ONNX Runtime has a lot of support for like batch inferencing, parallel inferencing. So provided these, and also like to touch upon like the couple of contributions which Multicore were made, adding process group support and like the parallel inferencing support in the performance benchmark suite which ONNX Runtime provides. All these things help in handling like huge data and like large inputs in parallel, utilizing like systems with like higher compute power altogether, and then getting the maximum frames per second, or detecting maximum number of boxes in a like whatever number of processing depending upon your application. It helps you achieve that particular performance.
Thank you so much, Sounder. As we're nearing the end of the Q&A session, let me just remind you once again, if you have any questions, you may pose it in the chat box anonymously or to any one of our speakers, or you may raise your hand and we can allow you to speak and ask the speakers directly. So we have another question right here. So Naveen, could you please take up this question? How is ONNX Runtime tailored for mobile deployments?
Specifically, like if you see the ONNX runtime, right, it's very lightweight and modular as we discussed previously. And similarly, when it comes for the mobile deployment, right, as for one of the questions like I answered, so it makes sure it runs it on the multiple hardwares at the back end. So if any of the hardware accelerators is being supported for the specific mobile phones or mobile phones as a DSPs or the NPU or even as a mobile GPUs or the CPU side, it supports it can run on the different execution providers for the same model by dividing into a subdivision of subgraphs or a single layer execution. By the way, like only one thing where for the NPUs or the DSPs, which is supported by the mobile devices, right, their inference engine or their execution, right, should support running the model in the runtime in the live. That means like without any offline conversion, they should support whether it is an quantized model or the float model, right? That support should be available for the backend devices. If so, then seamlessly like it can be deployed for the mobile deployment.
Thank you very much, Naveen and Sounder. As we have just come to the end of the Q&A session. Once again, if you have any questions, you have a couple of minutes more time. You can post it in the chat box. We will try to get it answered. Naveen and Sounder, my heartfelt appreciation for enriching the Q&A session. I'm sure that is the same for all of our participants here. And to all of our participants and registrants, we are diligently compiling all of the questions that have just been answered and any of the questions that are yet to come up in the chat box. We will be collating all of these questions and sending it to you all, along with the recording of the event. Once again, Naveen and Sounder, thank you very much. As we conclude today's enlightening session, our profound thanks to each and every single participant who attended this webinar. It is our sincere hope that you found this discussion enlightening and enriching, and I hope you learned something. Wishing you a splendid day or evening ahead, and we eagerly anticipate your presence in our future endeavors. Thank you very much. Stay safe and best regards to all of you.